Hello again. In this video we're going to talk about the law of sines again, and this time we're going to do examples where we have two sides and an angle on the triangle. Again, it's SSA standing for side, side, side. When we're looking around the triangle, it's that we're given, kind of going counterclockwise, given two of the sides and then the next angle that we see if we rotate around counterclockwise. Now, there is different possibilities that happen in this situation, and they're described here in the textbook, and I just want to illustrate them using a computer program called Maple and a file that I made some time ago. Alright, so in this example, what we're given is two sides. The blue are the given sides. This angle right here between this blue side and the red line, which is going to be the base of the triangle, are fixed. Now in this situation, if I rotate this side, we notice it makes a triangle there. However, if I keep rotating it, we cannot make another triangle because that side length is too long. So in this instance, we get one triangle and one triangle only. Now, I'm going to change one number in this file, and then I'm going to reload it and look at that picture again. Alright, now I've changed that side length so it's a little shorter, and now if we play this forward a little bit, we notice we can get one triangle there. Alright, just pretend it didn't cross over, where all the angles are acute. But now if I swing this side length over, it actually determines another triangle over here where now this angle is obtuse. Alright, so this is the situation where we get two triangles possibly resulting if that side length is not too short, but also not too long. Now the other possibility is that you don't create a triangle, or it's impossible to get a triangle in the side, side, side situation with one of the sides being too short. Now again, these two blue sides are fixed, this angle is fixed, but we'll see here, this does not come down and touch. Alright, so it does not create a triangle. And that's what's described in the textbook in these figures. There you have multiple possibilities. You could get one triangle, either a right angle triangle or one with all acute angles. You could get no triangle, or you could get two triangles possible for this side, side, side situation. Alright, so let's go over and work this out a little bit. I've got one example from the homework here that we'll look at. So it says use the law of sines to solve all possible triangles given this information. So the side length B, and we're just going to substitute it right in, is 50 degrees. So we'll just put 50 in here. So we know that side length across, side length A is 101, side length B is 48. Alright, so let's just try to find one of the other sides. Now, since we know side length A, let's try to find angle A. So that's what we're going to look for. Again, this is different than the previous video where we knew two of the angles and one of the sides. Here we know two of the sides and one of the angles. Okay, now let's put these in here. So we know side length little b and angle capital B, and side length little a. We don't know the angle capital A, so that's going to be our unknown. So sine of A over A, which I'm going to substitute in as 101 just to save time here, is going to equal side length, or sine of the angle B, which is 50 degrees, divided by side length B, which we're told is 48. Okay, now our goal here is to find A, so we're going to multiply both sides by 101 next. Alright, so to clear the fraction out, I'm going to multiply both sides of this equation by 101. We're dividing by 101. That cancels it out. That gives us, oops, do that in blue, that sine of the angle capital A is going to equal sine of 50 degrees divided by 48 times 101. Alright, now computing that with a calculator, let's see what we end up getting. If you do that on a calculator, the right hand side is what I'm referring to. You'll end up getting 1.6119 if we round it off to 4 decimal places. Now, from our previous experience, we would think, okay, well, the angle A we're going to find using inverse sine or arc sine. But if we try plugging this in, we will get an error on a calculator. All right, let's just go over to Desmos and quick compute that. So if I try doing, I'm just going to type it in because it's quicker, arc sine, which is the same as inverse sine of 1.6119, it's telling me it's undefined. All right, remember the sine and cosine have a range of between -1 and 1. They're corresponding to coordinates of points on the unit circle. They cannot be larger than 1. So this here is undefined. All right, that does not make sense. All right, so what is this telling us? A triangle with these side lengths is impossible. With these side lengths and those angles is impossible. All right, so sometimes my wrist with the keypad get in the way here. This is impossible. There's no triangle. All right, with those side lengths and those angles. That's fine. So that's one of the possibilities. We could get one triangle. We could get more than one. All right, the next example we're going to look at the possibility where we might get more than one. All right, let's take a look at this one. All right, so for this one, we are again just trying to find in here the missing information. We're given two sides and then one angle. And again, they're calling it beta. We're going to call that capital B. All right, so just give me a moment. I'm going to copy and paste the picture down and then we'll label it. All right, so let's label the figure here. We know this side length is 31. We know side length B is 26. And we're told that angle B is 48 degrees. All right, so let's try to find this missing angle here, capital A. All right, what we're going to see, and again, I've drawn it this way. All right, we're going to see that there's going to end up being two solutions to this, for two possibilities for the angle A in this scenario. All right, or we could find, well, no, that's what we have to find is angle A. All right, so plugging the information in, we don't know capital A. We know little a is 31, so I'm going to substitute that into the law of sines. We know the angle B is 48 degrees, so we're going to plug that in, and the side length B is 26. All right, like we did in the previous example, we were going to multiply both sides by the denominator on the left, which is 31. I'm going to skip that step. You can pause it and put that step in. That will clear the fraction. We'll get 31 times sine of 48 divided by 26. All right, now we will go through and use a calculator to compute that and then see what that gives us and then use the inverse sine to determine the corresponding angle. Okay, doing that on the calculator, we end up seeing that sine of A, if you do the calculation on the right hand side, it's going to give you 0.86886, I'm going to say 0.057, carry lots of accuracy there. If you don't do that, all right, just make sure you, this is not our final calculation, so make sure you carry enough decimal points first. We can always round later. Now we're going to do inverse sine. All right, so to find one of the possible solutions to this equation, there's lots of solutions to that statement, sine of your angle equals 0.866057. One of them we can find using the inverse sine. And if you do that on a calculator, you're going to see that that's coming out with 62.38, I'll go 19 degrees. All right, now that's one of the answers. That's one of the possibilities. All right, why do we get more than one solution here for this angle, capital A? Let's think back to the unit circle and what sine represents. We got the unit circle. Let's pretend that that was a circle that I just drew there. All right, it's a little better. Not perfect. One of them is 62 degrees. All right, and remember, sine is the y coordinate. There's another angle in quadrant 2 at that same height, all right, which is bigger than 90 degrees. Well, if this reference angle is 62, let's just say, well, I guess I'll write all of them down, then this angle right here also has to be 62.389. If we subtract from 180, we will find the angle going from the positive x-axis over. That angle here in red will come out to 117.618. All right, so the other possibility for the angle A is 117.6181 degrees. Alright, so there's two triangles that are possible. One of them has an acute angle for angle A, the other one has an obtuse angle for angle A. Alright, and there is questions in the homework, or at least one of them that deals with this. So let's finish it off. I'll do it in blue for the acute angle, and then we will do it in red for the obtuse angle. Alright, so we found the one missing angle, or one of the possibilities. Alright, so let's just call this option 1. We've got A is 62.3819 degrees. Now if we add on 48 and then subtract from 180, we'll find the missing side length C. So the side length C is going to, or the angle, pardon me, the angle C is going to be equal to 180 minus 48. Remember that was the angle we were given in the problem. Minus 60, keep on writing 1, write a 2 there, or 3, 62.38.9. Let's compute and see what that gives us for the missing angle. And what we're seeing is that side length, or the angle capital C, excuse me, is 69.6181 degrees. Okay, so that's one of the possibilities. Alright, now just for time in this video, alright, I'm just going to go up and label, and then I'm not going to find the other side. And again, keep in mind that I can't change the side lengths of this picture, so it's not going to be perfect. Alright, when I go to write in the red sides. So this angle C we just came up with was a 69.6181. The angle A was 62.3819. Alright, now for time purposes, I'm not going to find the missing side length C, but that can be found just like we did in the previous video using the law of sines. Alright, so I'm just going to skip that because I don't want to take the time in the video, but it's the exact same type of calculation. The other possibility, let's do that in red, would be if we used the obtuse angle. So for option 2, the angle A for the other type of triangle, and think back to that maple animation that I showed, would be 117.618. So then the angle C that would be missing would be taking 180, subtracting the other two angles, subtracting the 48 given in the problem, minus the 117.618. And what do we get when we compute that? We get, doing the calculation here on my calculator, we get that this angle is quite small. It's 14.3819 degrees. So the second option would be to have that angle for capital C, and then we would have a different side length little c, which we would need to find using the law of sines, which again I'm going to leave out for this video. Might make one more dealing with an application problem or so with the law of sines.